So today, I'm super happy and stoked that today Rick McLaughlin came all the way to Štvanice, and first time I heard from the States that Rick was involved in the development of Egress. And he's a pioneer of adjustable waves in the States. Like he broke ground for the whole rip surfing community. And as far as I know, it's the first adjustable wave that was built in Egress. And Rick just told me he never surfed basically his own wave yet. But past the summit, he will be there surfing. So finally,
Yes.
you can check out that wave. So thank you very much for joining our community, and we're very stoked to have you here. Thank you, Rick.
Thank you. Thank you. Very humble to be asked to be here and really excited about it. I'm not sure if I'm here for this or to go surf, but so my talk is on safety and related to design. It's kind of interesting that you're asking me to talk about this. This is a venue that I designed about 10 years ago. This was on the first day. The first draft was me and my 90-year-old father, but they decided to do the opening day before any of the guys had ever run this rapid. And immediately after this, they shut the thing down. And this was one of the few times where I really wasn't worried because I had spent a lot of time on this. This is not something that I wanted to design. This is the most difficult rapid that I've ever designed. But that's kind of what those were the cards that we were handed. This is the 1996 Olympic Whitewater course that we designed. It was also very difficult. A number of the Olympic competitors actually swam this course. So this is the only venue that I didn't send my kids down. I was told, I've read that back in the days in Russia, they had a lot of problems with bridges falling down. And so this is the Soviets, and what they finally did is they made the design engineers stand under the bridges and loaded them. And from my perspective, those guys were wimps because pretty much everything that I designed, I sent my kids down. And my kids aren't like super athletic or anything. I mean, one's in band and the other's in theater. But when my wife wasn't looking, I sent them down there. So even though I've designed those kind of more extreme things, most of the things that we design are for kind of the weakest swimmers, just like we designed a fish passage, right? You design for the lowest common denominator, which at the time was my children. Just real quick, going back in the 70s in the US, the EPA was formed by none other than President Nixon. And back in Colorado, that's John Denver there was a real resurgence of kind of preserving the environment. And then also on the recreational side, the engineering company that I joined and later was an owner was very much into outdoor recreation and integrating that into infrastructure. So this is like a tennis court, or this is a water tank that we built tennis courts on top of. This venue here was an old dilapidated drainage way, and to turn it into a nice park. And then that's a wastewater treatment plant up in Snowmass, Colorado, right next to probably the most prestigious athletic club there. So really, there was just a general focus back then on kind of integrating regular infrastructure and recreation. So my mentor actually, a guy named Bill Taggart, designed the first in-river whitewater park in the country. Of course, people have been throwing rocks in rivers forever. and there's a number of, there were a few that were built in channels, but this was the first, and that was in the mid 70s. And it's at Confluence Park in Denver. This is what it looked like when I was growing up, and this is what it looks like today. I redesigned it in the 90s to what you're seeing here. It's functioned all those years with no serious safety incident, and it's never had a rock move or needed any maintenance at all. So it's not particularly great for whitewater, but it's just used by all sorts of kids all the time. So again, when I got out of school, I was a kayaker, and I had my own Radio Shack TRS-80 computer. And so I went to work for my mentor, Bill Taggart, who had designed the first one. And up until about the mid-90s, it was kind of a paid hobby. But after the design of the Olympic whitewater course in '96 and my redesign of this, that's where my career's been pretty much focused. Every time I would go out and talk to people during the sessions, I'd learn something, and then I'd run upstairs and change my presentation. So I have no idea what's next. But it was really interesting to kind of see the difference in the progression of the venues here in Europe and what's gone on in the States. And I think there's, I guess the really cool thing about my job is either I'm really stupid, well, which is probably true, but I learn something all the time, and it's just amazing. But I think there's some differences here, and one is, like, in the U.S., most of the river parks are run of the river, right? There's no lifeguard or operator, and they're river parks. They're in free-flowing rivers, and so they have to go through all the different variations in flow and so forth. Nothing's controlled. Users, most are kids in a lot of parks, or young people, all sorts of recreational crafts. So not too many specific features that are designed just for surfing, although there are, but usually they're integrated into an overall river park. And then liability is very different. So in the U.S., the liability is out of control. But if you don't charge for the experience, all the laws that govern ski areas kind of kick in, and there's a lower liability for these type of venues. And so this is a study that was done, and actually it was done before the kind of the resurgence of surfway parks. So the first surfway park that had a specific surf wave, I think did in 2012. But this is a study that was done as part of the PhD program. But they went around to like 13 different river parks and found that 3/4 of the people that use these parks never get into the water. They're spectators. And of the people in these parks, 40% were kids, and at that time, kayakers represented only 2%. And now I'm sure this is different, at least in venues with surf waves. But so that's kind of what we're up against there, and I think there's some differences that are result from that. So the first, so basically I'm going to cover these three kind of topics: sound recreational hydraulics, site safety considerations, and design criteria. And so this is Confluence Park. This is what my mentor designed, and didn't really know how to do things. It was the first one, and he designed, I don't know if you know what an OG Crest dam is, but a typical drowning machine kind of dam, but it works. So he designed those, but to make it safe, he only made the drop like 6 inches. So when I was growing up, I probably seen 24 canoes just crunched in this thing, because even though they're only 6-inch drops, they're pretty sticky, which is one of the reasons that I redesigned it in the 90s. Back then, was kind of the first when I started, and we were trying to figure out the basic recreation hydraulics. And so most of the hydraulics, the theory and stuff is done in the 50s and 60s, a long time ago. Of course, now we have CFD models on all sorts of stuff, but the basics are pretty much the same. He went back and found something called the hydraulic jump at an abrupt drop. And so I researched it, and of course, and did all that stuff, and found out that this was heavily investigated, but because at some flows it causes big wave, they never used it. Because if you have a big wave, then you have to armor up and all that stuff. So it was largely forgotten until, at least as far as practical use, until my mentor kind of figured that out. So pretty much everything I've ever done is based on the hydraulic jump at an abrupt drop. And since we talk about that a lot, I refer to those abrupt drop jumps or ADJ drops. So basically you have water flowing down the feature. This is the flow here, and then the wave forms. But basically, you have this drop in the channel bed that stabilizes the wave. And so, like, if you float and want to breathe, you want the surface currents basically going downstream. And so we first employed that, a much younger and thinner me. This was a really cool model study. This is the first kind of project I worked on. This was actually built. I never went to it until about a month ago. And it was really cool to see it after all that time. But we really kind of worked on the refinement of the wave and how to create that over a wide range of flows with all the considerations that go on when you have to look at something in a river. So my career started pretty much there, and pretty much everything I've done is based on that. Building upon that, I later patented, at least in the U.S., what we call a wave shaper, and basically this is actually one of the wave shapers in Boise. It's pretty unique, but basically it has some adjustability, an adjustable trailing vane. This one also has an adjustable entrance gate, and so most of the things that I've designed, rather for either for kayaking or surfing, the high performance ones are adjustable, and that's for a lot of reasons. But in river conditions, particularly with waves, as y'all know, waves are very sensitive, and one of the benefits of having adjustability is, you get deposition, right? Rivers move a lot of sediment and cobble, and it's always changing. And waves are that sensitive that the deposition downstream affects the wave. And so adjustability is pretty cool because you can account for that real time. Not only that, but you can adjust it to all sorts of different waves. So we'll go out and adjust a feature, and everybody will go get a different board and all that kind of stuff. So, but basically, it's still a hydraulic jump at an abrupt drop. This is Boise. This wave shaper is unique. It's the only one of its type. It doesn't really have the big sidewalls, and it also works extremely well for both freestyle kayaking and surfing, because of course you've got good eddy access for kayakers and so forth. But they adjust it. They have a setting for, and they have days that they do river surfing and days for kayakers. That's Paul Primus, who spoke last year out cutting it up. Unfortunately, Paul is about the same size as me, so like if I fade it out, I can pretend it's me. This is a more recent surf wave that we did in Denver. We don't have much water in Denver, hence most of my work now is not even in Colorado because the streams are so intermittent and the flows are low. There's a lot better places to do it. But anyway, but this was the first kind of low flow feature, the surf feature, and it's not particularly wide. This I think is 15, 20 feet. Sorry, can't convert that. Was that 4.5 meters or so? So anyway, but it works way at very low flows, and which is what they have. And so anyway, this is kind of the first feature that was focused towards that lower flow. And surf waves or green waves, like we try to call them green waves because they're really for everything, but they're the lower the flow, the harder they are to generate. This is we just opened up this venue last year, and it's in Tulsa, Oklahoma. And like a lot of these places, in the middle of wasn't really a strong river community, let alone river surfing community. But within the first week, there was a whole cadre of kids and their dads, dentists, everybody out there cutting up, and it was really cool to see. It's a narrower feature, but it's very powerful and strong, really different. And of course, this is the feature that I'm coming to see for the first time in real life. Sound recreational hydraulics, and for me that's a hydraulic jump and an abrupt drop, because it can go through a lot of varying conditions that river sees, but there are ones that have been designed and built, not by me, but that have had problems like this. 15, okay, cool. So you can have those same kind of retentive conditions, right? So instead of kind of surface currents going down, and so kids and me can breathe, if the tailwater, this is the tailwater, that's the headwater, in any case, but if this thing collapses and seriously collapses, then you can have these surface currents, instead of going downstream, going upstream. This is kind of the boil line, as you might know, but not a good condition. There was one that was built, and they kept having this problem, and then you get the walls on the sides, and there's kind of inescapable. So something, of course, you might avoid. And then, of course, there's a plunging condition where you kind of get the same thing. If the relative tailwater is too low, then you have the same kind of condition. So a lot of times we refer to these as submerged jumps, or submerged hydraulics, which I don't really like, because like this condition is not submerged. So I refer to them as overly retentive hydraulics, right? You can have a retentive hydraulic. In fact, you want one for kayaking, but you don't want overly retentive, and there's that condition is created more than just a submerged hydraulic jump. So, and again, the A form and B form, that was all figured out by people a lot smarter than I am back in the 50s and 60s, and so we kind of adopted everything that they learned back then. And again, this is one that was built, and when you're in a real river, right, and you can't control the flows, if you get a condition like this, it's not good. And so that's just because you have a hydraulic jump at abrupt drop does not save you. The other issue too is, so from a basic standpoint, there's not a lot of difference between a kayaking feature and a surf feature, right? Still hydraulic jump and abrupt drop, if that's what we're doing. But when you, a surf feature is a lot more tricky, obviously just because of the waveform itself, and also it requires more drop. So drop is the difference between the headwater or upstream water surface and the tailwater, and that's the energy. Well, it's close to the energy, but that's the drop, and that's the energy that goes into these features. So with a kayaking feature, you can do a really good one from 6 inches, whatever that is, to 2/3 of a meter. But for a surf feature, I think it's you need about a meter. So when you have a bad condition, you've got a lot more energy to deal with, and it makes it a lot more dangerous. So I've done about probably 24 big physical models in my career. It's been super fun to be paid to play in a sandbox. But of course the 85 model, and then this one was, remember when I showed you that turbulent rapid? One of the reasons why I wasn't worried, I actually threatened to walk away from that project if the owners didn't let me do this model, because I knew it was going to be super powerful. way beyond what I've ever done. And so they built me this thing was huge. It was but I modeled the entire rapid, and that's why I wasn't worried when I saw everybody flip out, because I knew that they were shooting out of there, again, a very disguised version of a hydraulic jump at an abrupt drop. So, sound recreational hydraulics. Every project I do, whatever it is, starts as the same thing, application of solid theory, right? What are we doing, what's the intent? And then modeling, if I haven't done it before, I still do physical model, or if it's complicated, whatever. And now we're doing a lot of CFD modeling. There's pros and cons to both. And then experience, right? There's nothing, there's been a lot of CFD models and physical models of surf waves and things else that the projects themselves have not been good. In fact, safety problems. Just because you do a model doesn't save you, right? And in fact, I know what the model should show, right, in general, before I start. And so you just can't rely on a physical model. In fact, the Boise project, which is actually new, or was a different thing, I didn't even do a physical model, which I should have. Anyway, but so sound, recreational hydraulics. Then the other thing is site safety considerations. So there's different ways to form surf wave or river park, whatever you're doing. So you can do a full river kind of width feature structure, just like a natural rapid. You can do what we have out here, right, where you have a dam and then a bypass, which is also Confluence Park, right? It's the dam and then a bypass. Or you can have a course that's totally offline, well, it goes out of the channel and you can control the flow. But those are kind of three of the more typical configurations. But you see that dams are involved in those, or some kind of structure. And of course, this is what happens when things go awry. This is the hydraulics that's occurred, right? This, what we call supercritical jet, or this fast water comes screaming down here, hugs the bottom, something called the Coanda effect, and then screams out the bottom, and then you get this recirculating current that tends to trap you. You can have the same thing if you're not careful. This is a feature that actually Paul talked a lot about it last year. Same kind of hydraulics. A lot of times, so that's the dam part. And then often we have gates and things. I once interviewed on a job and they had a gate right next to this park that they wanted. And I said, well, you can't do that. And he said, well, why? And I did this thing just for their proposal, and they go, well, you don't know that's going to happen. So everybody in this room, probably, if you're familiar with the rivers, know that there's going to be a problem. And the worst part about this one is that it's not apparent. Like a lot of low-head dams, right, the hydraulics, the danger is not apparent. It doesn't look terrible. So, and I'm going to come back to that. So, site considerations. So on the dam, this was the Confluence Park, and what we did here is we built a stepped dam, and that was probably the first low hazard dam built in the country specifically for that, and that again was in the mid 90s. And I couldn't help but throw this slide in, but this was a project actually where this is the intake for a big intake for water, and it's actually on the bottom of one of the recreational features. So you can't even see it, and it works really good. Not intuitive why it would work, why you would think putting a screen on the bottom of a river, and this is a very unstable river, would work, but it does great. So again, you're looking at all the site considerations and what's going on. The other thing too is you have to worry about like what's going on downstream, right? If you don't recover, then you have an issue. So, and so then I kind of lumped a bunch of things into design criteria. I authored the only two kind of in-river design manuals that focus on in-river recreation and river corridor recreation. So I'll hit upon a few of those concepts. This again is that step dam at Confluence Park, and I would never design this again because it looks terrible, and it would be terrible. But believe it or not, it looks so bad that nobody has ever gone over it that I know of. I don't have the guts to do that again, but so one of the key things, and I didn't develop this, a guy named Charlie Walbridge did, who actually wrote the part of the class 1, 2, 3, 4. He's actually one of the guys that wrote there. But anyway, his observation was basically things should look as dangerous as they are. Right? Low head dams don't look dangerous. I've had kayaking friends that have been killed in them. They just don't look bad, right? And compared to what you just saw. So things need to look as dangerous as they are. This dam looks dangerous. It's not. In fact, it's never going to trap you. But that's a key thing in design. Egress access. Can you get out of the water, right? So this is actually the only recirculating course I've ever designed. This is on a, this has actually been used for World Cup slalom and World Cup freestyle events. And actually the reason why you could do that was because of the wave shaper, the adjustable gate, which was used for a different purpose, which is actually the first one I ever designed. But you can see this is designed like a natural river, right? And so you have eddies, you have egress on both sides. Big on egress.
Better use mine. Can you use this one maybe? Sorry.
Okay. So the other thing is structural soundness. I did a study for the state of Colorado probably 10, 15 years ago, found out that 75% of the in-river recreational features had failed, fallen apart. So my definition of failing is if it moves and it creates a condition that you can't fix right away, that's a failure. And so, not yet. Can y'all hear me? I'm not particularly.
Yeah, maybe just a second. Yannick, sorry. Try. Yeah, it's just 1 second.
I'm just glad the presentation is working.
Sounds like it's
Test. Test. I don't think so. Is there a switch on there? Nope. Okay. Oh, it's better. So, of all the projects that I've done, I've never had any reasonably, I've never had anyone drown or have a serious accident. At least of people that have just not fallen in the river drunk or whatever. And I've never had a venue that's needed any maintenance whatsoever, or had any kind of structural failure. So that may be over-design or careful design, but I sleep at night very well. So anyway, but when you have a recreational feature start to fall apart, right, there's safety implications. Worked on one in Wyoming where it was undercut and a guy got swept under, drowned. Worked on another one where where a dog, same thing. So very big on making things robust and expensive for upfront costs, but what you call life cycle costs, right? The cost of the project throughout the thing. In my opinion, it's well worth it to design these things bomb-proof. And so again, I actually have a slideshow, and I have about 20 of these slides, just different projects. But this is one in Glenwood. It was designed, it actually fell apart and creates a really good surf wave at high flows. However, and it was only because it fell apart. But at low flows, it creates that pour over condition, and there's been some issues with that. Fortunately, there's been no drownings, but again, I've got a whole bunch of examples there. So wrapping this thing up here, there's a lot of other criteria. So again, most of these things are run to the river, so I always want a portage path, which is often difficult because private lands, but that's one of the things that I will walk away from a project on. If I can't get a portage around it, I'm not going to be involved in it. If I can't eliminate site hazards, I'll walk away, and I have. But in any case, but there's a lot of other criteria. Some applies, some of this criteria is made for engineers that don't, or designers that don't, they're not in this field, so you have to have kind of more generic criteria. But in any case, the maximum drop in a feature, maximum slope of the feature, signage, guide boulders, right? So you can see where to go if you're running down the river, buoys. And then peer review a design, right? And then recovery zones and things like that. So there's a bunch of criteria. This is on the the Tulsa project. And again, lots of different weak swimmers, I guess. But this thing has worked very well, and it's used by all sorts of people. It's in a very big river. And this, I think, was close to opening day, so it's pretty cool. So anyway, with that, concludes my presentation. So how did we do on time?
Perfect. That was really nice. Timing-wise, it's perfect, Rick. Thank you very much. Any questions about Yannick? I think.
What's a guide boulder? I don't know what it is. Can you explain it?
Guide, yeah. If you use enough jargon, you sound knowledgeable. But anyway, so a guide boulder is simply, so if you've got a big river, right, and you're coming down the river and you don't know where to go, what we typically do is put a couple of boulders or rock pods that under normal flows you can see where to go, right? You go between the two boulders. That doesn't mean that if you go the other way you drown, but that's the preferred route. So that's a guide boulder, and again, it's for more of this run of the river thing. So on the South Platte through Denver, I think they've built like 40 different features to make the whole thing what we call a blue way. So you can boat all the way through the metro area about 20, 30 miles. Because every feature has guide boulders and recreational drops. They're not, not all of them are really great, but they're navigable. So.
Any more questions? Yeah.
Rick, what ideas do you have for the future of river wave design in terms of where could they go to?
I could have a whole presentation on that. I am fascinated with World War I and World War II aircraft, and just the development of planes. I have been since I was 5. But I think we're in the World War I biplane state right now, right? We've learned to fly. We've got the basics down, but I see a lot of cool things, and I hope that I live long enough to see some of them implemented. One of them is, so we talked about drop, right? So drop times the flow is what? Times a constant, actually. But the drop in the feature times the amount of flow is close enough, is power. It's actually horsepower, right? So a lot of these, it's just like if you had a boat, and the more horsepower you have, the bigger the whatever you can do, or more things that you can do. The problem with the wave, though, something called the Reynolds number, but so you would think, right? You've got so much flow, whatever's coming at you, and you think, okay, we're going to make this really big, right? And so you make it high, but what happens is you have more horsepower, but it's not very manageable. And so there's several ways to convert drop energy to flow. And that's a big one for me. That's what I'm working on. That's what I really want to do is how do you build something, say, with 2 meters of drop that it turns out to be a really cool big wave without being a turbulent mess. So That's one thing. We're always working on shoulders of waves, right? So like a feature, like a lot of the features we design are small because of the flow. So the shoulders, right? How do we make it so that you just run in the wall, right? How do you bank off, right? Because if you've got nice shoulders over a wide range of flows, right, and you can make a narrower feature work really well, which in Tulsa is what's really great. So it's not very wide, but it's got nice shoulders and things like that. So there's a lot of those nuances. Recovery zones, like in Tulsa again, when you fall. So for me, this is what I designed for the really weak swimmer. So when I fall in, right, I go out and you naturally get carried back up through this boulders things. It's a really cool experience. You just kind of drift back up right up to the thing. So the recovery zone and the return is awesome. So that's kind of a more recent development. Safety again, and simplicity, right? Nobody ever has asked me, hey, go build me a mechanical nightmare, right? Or a mechanical thing, right? It's like they want simple things, which they should. And so when you build something first, you do it very reliably and solidly, and then when you get more experience, you can start scaling back. So we're scaling back, making things simpler, easier to operate. Every project we get into, if you make this adjustable or that adjustable or tunable. So tunable is like one-time adjustable, basically blocks. So a lot of the things we build now have concrete blocks that you can bolt in and bolt out, right? They're not these wimpy plastic things. They're solid, they'll never move, but you set them up to get all these nuanced things and bolt them down. So that's a tunable feature. And then a real-time adjustable is like I said. So, but we're always working on it. But there's always a drive to make things more complicated, right? Let's have this move up and down, or move in and out. And so, because of money and because of reasonableness, you got to limit it down to something that you can afford and so forth. So I see a lot of improvement there has been in the last 2-3 years for that. I mean, what's more important to make adjustable? And then, so very long-winded question to your answer to your question.
Very good, thank you.
Anything else? Yeah, sir.
Do you think shapes of waves will also change in future? So we see that very glassy, steep waves right now. Do you think the shapes will also change in future?
Absolutely, absolutely. So with like the features that we have now, right? You can adjust them and get different types of waves, different steepnesses, and different play areas, different types of boards. Of course, the holy grail is to make a tube, right? That's what I really want to do. But I've seen people come up with models and things, but if you miss it, you run into a wall. When you're in a river, you just don't have that flexibility that you have in a wave pool or whatever. You have to worry about, again, the weakest swimmer, me mostly, and then debris and reasonableness and all that stuff. So, we can do it, but not reliably, not big enough. That would be cool. So Paul Primus, who spoke, he likes more dynamic things. He doesn't like that glassy, smooth thing. He likes things that are moving a little bit, and again, that's a level way above that I can even relate to. But I think kind of diagonal waves too would be cool. Not just a straight head-on thing, but something that you can adjust maybe in real time that can go not be uniform across the river. That's very doable. I think if some of the future features, if I still around, we'll be able to do that. Just kind of mixing it up. So, but I think, so anyway, does that, I think those kind of things, I don't think, at least in my lifetime, we'll get to a reliable tube wave. I wish we could. But generally, and again, it's like what you have here, like it's really cool. It's like a full-scale model, right? You can shut the thing off and do it. Most of the things I'm involved in aren't like that. They're in a real river. And that's one of the reasons I tend to do a lot of analysis and design, because I only want to do it once, and I don't have that luxury of being able to shut it off and do all the cool things. But anyway, and then waves that take a lot less maintenance. But as far as the shape of wave, I think getting things that can go diagonal so it's not just a uniform straight across the river would be fun, particularly if you can do it both ways so it's equal for everybody. Yes, sir.
So one thing that comes into my mind when I compare the waves that you showed in your presentation to the ones that I know, the ones that other people show from Europe, is that we almost always have like straight walls, and the wave looks very symmetrical from one side to the other, where your waves look more natural with like natural stones on the sides. Is that something you strive for in your design, or is that something just because they're all built in natural rivers and you want to change as least as possible?
Yeah. So the most flow efficient, energy efficient design is vertical walls, right? So the lower the flow that you have, the more verticality you have to have. But again, that's been a goal, is to make things look and feel more natural. And so the Boise wave, design 2 of them, Wave Shaper 3 is very much walled. The one that you saw is not. And so, you know, I've been trying for 20 years to get rid of walls, right? And because they're just not, they don't look good. If you have a bad condition, you're trapped there. But they're economical and they're the most efficient, right? Fun per dollar is best.
I have a question just out in the blue, because referring to one of your first slides, you compared the liability situation in US and in Germany, and I think when I'm seeing what you're doing, this is something a lot of people in here or in the community are looking for, to have a natural river and designing in this way. And what you're doing, like you have like a thing which is like river recreational parks.
Yeah.
This is nothing which exists here, I've never seen, or maybe in some areas. But preparing the preparation, or in general, did you make any thinking or comparison between European and US legal system? What could be maybe approach for us? So like a next step to come more towards in your direction would be very promising.
Yeah, and again, I just really am realizing that now. I kind of sensed that before. But yeah, I think, you know, in building a river park, right, and in opening up to more of a park, right, it builds more of a community kind of a thing, right? I don't know, 10, 15 years ago when my kids were learning how to skate, I'd go to skate park and, you know, they were really cool and they're a lot cheaper, and I was going like, wow, what am I doing? I'm spending millions of dollars on this thing, and it's just as fun to go. But then I looked around, right? There was like one dad or two dads out and, you know, 20 kids going. And so the mark of a really great venue in my mind is, can you meet that 75% of the users are watching, right? Or the surfers, kayakers, you're just the entertainment, right? And so in a lot of interviews and things, I say, look, I'm not designing this thing for you, right? You're just, you know, I'm designing it to get those, to host those 75% of the people. Of course, to get them there, I've got to give you something cool to look at. But my target is actually not the surfer, right? It's making this, and kayakers. Fortunately, kayakers and surfers are bright enough they get it, right? And kind of the only pushback of these projects that I've gotten is like, oh, you're spending all these millions of dollars for these elitist, you know, white athletes. It's, you know, no. Well, yes and no. But and I think the other thing that does is it broadens up. You get more user groups, more interests, and guess what? You get more money, right? If you integrate a fish passage and things into it, guess what? You've got more funds, right? So you can build a better, cooler project. So the more interest groups that you can get into a project, again, I could do another presentation on just that. But I think that's really cool. You know, what I've seen here is you guys are doing really awesome with doing low budget surf waves, right? And what waves are, from what I see here, I mean, they're great, but very unipurpose kind of things.
We have the audience as well. But yeah, but I like the approach like
Yeah.
this. So very good, very enlightening. Well, thanks.
So, anything else? Well, again, I really appreciate to be invited. Everybody here is so friendly, and when I was younger, I went to school in Northern California, and I thought I'm going to move down to Southern California and like switch from kayaking to surfing. And you know, surfers are assholes. I mean, plus they're really big and strong, and I got the crap kicked out of me. So I didn't live in Southern California very long because they weren't like kayakers. I thought it would be, you know, and I've really seen here, if this is my, in the U.S., that river surfers are more like the kayakers. I think it's really cool. So, and this is a great community. So, anyway, thank you.